I swear I'm going to start keeping the outtakes. This is like my 7th try to get this video started. So let's talk about while loops for CS 141. So learning goals, while loop's an indefinite loop. That's different than a definite loop, which is a for loop. We've got motivation, and then we've got some of the nuances. Now we had our Lord of the Rings quiz. We don't assign this every year, but it's basically a nested if statement assignment where you've got a menu-driven system. So you're going to say enter 1 or 2. We're going to read in the number that's entered. And then if it's 1, we do a bunch of stuff to handle option 1. Else if it's 2, we do a bunch of stuff to handle option 2. And if it's not 1 or 2, which are the only two valid options, we just give an error and the program exits. And so the motivating example here, what if we want to be able to go back and tell the user, hey, I asked you for 1 or 2, you entered -17. That's not 1 or 2. Do it again and keep doing it until you give me either 1 or 2. So loops in Java, there's actually only two kinds of loops. I know it may seem when you're first learning introductory programming that there's just an infinite amount of new stuff. There actually isn't. You've actually learned a huge amount of Java at this point. So there's for loops, which is a definite loop. We call it a definite loop because we know the start and stop conditions. So we know more or less how many times the loop body is going to execute. Now, it might be a variable number of times. We might be able to say, well, it's going to execute n times. We may not know exactly what n is, but it's some fixed number for the most part. While loops, this is an indefinite loop. We don't know how many times the loop body is going to execute. These are actually the only two kinds of loops in Java. There's not like 57 more kinds of loops. There's a thing called recursion we'll learn later, but that's not really a loop. So the basic syntax, we've got while some condition is true, do the body, and so long as that condition is true, we're going to keep doing the body, come up here, if the condition is still true, we do the body, and so on. Once the condition's false, when we check the condition, the loop ends, and then we do the rest of the code. Here's kind of a more flowcharty version of that, so we've got the condition. If it's true, we do the loop body, then we go back up and check the condition again, and we keep doing that, staying in this loop until the condition's false, at which point we jump to the rest of the code. Now the basic syntax of a while loop is going to look like this. We'd have a print line, enter a positive number. We're going to read in an int. While the number is less than or equal to 0, in other words, while it's not positive, print, hey, enter a positive number, read in another number. So we're going to keep doing this loop until they finally enter num, where it's greater than 0. And then once they do, we're going to say, you entered the number. So other issues related to while loops. There's a relationship between a while loop and a for loop, which we'll kind of see. I got to show you how to kill a running program, because when you start doing while loops, you're going to run into an infinite loop. A little bit about scoping, breaking continue statements, and 3 different structures. So anything you can do with a while loop, you can actually do with a for loop. This little code segment here, where we initialize I to 0, while I is less than 10, print I++, believe it or not, that's actually a for loop. I mean, it's not literally a for loop because it's a while loop, but it does the same thing as a for loop. We've got an initializer, here's our condition, here's the loop body, here's the update statement. Right? We can imagine this looks very, very similar to a for loop. So let's try this out. What does this print? I'll give you a second to go over and try to answer that. Did you come up with? It prints forever? If so, you're correct. This is a classic error pattern. We mean to be counting downwards, but instead we have I++ instead of I-. Now we saw a very similar type of error pattern with a for loop. Turns out you can do the same thing with a while loop. Now at this point, when you get an infinite loop, you've got to learn about using the barbershop poll in BlueJ to kill it. I'm actually, since I'm sort of live recording here, I've got this really simple version of an infinite loop. So this is the simplest infinite loop there is. While true, well, true is always true, so there's not even a condition to evaluate here. This is just a literal value true. Print blah. Let's go ahead and run this. Oh my god, it keeps printing blah. This is really annoying. We come over here to our spinning barbershop poll, we right click, we reset the virtual machine, and you can see this has stopped printing. We're good to go. So being able to kill an infinite loop, very, very important thing to be able to do. Okay, so let's try this one. Which of these compile? Let's assume that the scan and the print line are okay. We're just kind of using a little bit of pseudocode here. Which of these will actually compile? So I'll give you a chance to head over Try this out. Did you come up with program 2 only? If so, you're correct. And the difference is we're creating this integer variable num. We're reading in num with a scanner. We're checking while num's less than or equal to 0. We're saying enter a positive. So it's basically this loop. Here we're rereading the value of num and then checking it again. Over here we're creating this integer num, but then we're creating another integer num. This integer num is actually visible here, so that's a conflict. Num's already defined. This is a scoping problem. So this is back to our good liberal arts metaphor, variables, brackets, and medieval serfs and what they have to do with scoping. So variables are like medieval serfs. They're born in the scope of their lord's brackets, and they can't legally travel sort of upwards to their lord's lord, but they can go to their lord's vassals. So going back a slide, actually maybe going back 2 slides, num here exists in the scope of the brackets, probably of Maine, right? Now, these brackets are a vassal of Maine, so num can go inside here, which means that this other num, this name conflicts, so that's just not going to be allowed. I think there might be a Game of Thrones reference here, but I'm not quite getting it. So this is our basic problem. This'll work, right? Num is born here in the brackets of Maine. Well, Maine is the lord. This while loop, the brackets here, that's the vassal. Num is allowed to travel inside here, so this is fine. We can reassign it. We can't create a new thing named num because then they'll collide. And this summarizes essentially what I just said. You don't want to make the lord of the fiefdom upset. Break and continue. These are 2 special loop operations. They work with both for and while loops. Whenever you get to a break statement, it immediately exits the loop. So it just goes to the bottom of the loop, and the loop is over. Continue, if it's a for loop, will apply the update and recheck the condition. So continue essentially goes to the top of the loop. So when you get to break statement, you immediately exit the loop. When you get to a continue, you go to the top of the loop and then continue from there. And if it's a for loop, you apply the update. So I'll give you a chance to pop on over to Moodle. Try this one out. Did you come up with 11? If so, you're correct. Now here's what's happening. Count is getting increased while the loop's running. But when I gets to be greater than or equal to 10, we break. Well, we start count out at 0. We're going through our loop. This for loop's going to try to go up to 100, but we're actually going to break as soon as I gets to 10, but greater than or equal to 10. So I's going to take on the values 0, 1, 2, 3, ... up to 10. Well, 1 through 10 is 10 numbers, plus that 0 is 11. So count, because it gets incremented before the break statement, we would get up to 11, and then that's what we print for count. When we get to this break statement, bam, that for loop's over. We just come down here and start executing whatever's at the bottom of the loop. Let's try this again. Try this one out. Did you come up with 6? If so, you're correct. What's happening here, we're iterating the numbers from 0 to 10. Well, really 0 to 9, because we're doing strictly less than 10. So that's 10 numbers, 0 to 9. But if we see something between 5 and 8 inclusive, well, we're going to continue. Well, let's think about this. There's 10 numbers from 0 to 9, 5, 6, 7, 8. That's 4 numbers that we're not including, because when we get to this continue statement, we just jump up here, we apply the update, that's it. We don't do the count plus plus. Count plus plus only happens 6 times. The other 4 times we actually get to the continue statement, so we don't update. Using break to end a useful loop. This is an awesome technique. I actually use this all the time. I write a lot of things that look like infinite loops. While true. Well, true is a condition, it's just always true. And then we print enter a positive number, we read in the number. If it's greater than or equal to 0, we're going to say, hey, that's positive, and then we break. That ends the loop. Fantastic, I managed to read a positive number. If we didn't enter a positive number, we get to the bottom of the loop, true is still true, we say enter positive, we read another number. Now, looking at this, it kind of looks like num gets created, a new one every single time the loop runs. Turns out Java's smart enough to know that doesn't need to happen, it just creates num once. So we've got true, we've got break, looks like an infinite loop, not an infinite loop because there's a break statement. Another really fun trick with while loops, you pick an initial value to ensure the loop happens at least once. So here we're trying to read a positive number. Well, we want to make this loop happen at least once, so we initialize x to -1. -1 certainly less than or equal to 0, so we print enter a positive number, we read a new value in, if it's still less than or equal to 0, we do it, we keep doing this until we finally enter a positive number, bam, we've got the positive number. Now the advantage to this pattern, as opposed to, going back a slide, this previous pattern, if you look at this pattern here, num is created inside the loop, not created outside the loop. So that means that num's only usable in the loop. So once the loop's over, we can't use num anymore. Here we can use num because we created it outside the loop. That's an important distinction to keep in mind. So we're picking an initial value that forces the loop body to happen at least once. Right now, it doesn't matter what value we pick as long as it's less than or equal to 0. So what's the advantage to while true and the initial value approach? This is not a clicker question, but kind of think about this. I'll give you a second to think about it. Well, we're only prompting to read once, right? We're saying enter a positive number, we're reading something in once. We're doing the same thing here. So by setting this initial value and having a while true loop, we only have to prompt and read once. Now, if you remember before, here, look at this. We're prompting and reading, then we're saying while num's less than or equal to 0, well, we got to do the prompt again, and then we got to read again. This is kind of annoying. Sometimes this is called a loop and a half, because you've got your loop, but you've got this like extra chunk of code up here. And the more complicated this code is, right, the more lines you have to cut and paste. And so if you change it in one place, you got to change it in the other place. Maybe we're reading for negative numbers or something like that. Over here, we're just prompting and reading once. This is a big advantage. It's a little bit more elegant, fewer things to screw up or make a mistake. So while loops, these give you a lot of flexibility. But you have to really think about what you want the code to do before you start writing, right? You don't want to just sit down and start hacking code with a while loop without having a plan, any more than you want to sit down and write a freshman preceptorial paper without an outline. Of course you need an outline. There's a saying in computer science, hours of coding can save you minutes of thinking. This is actually true for paper writing as well. Hours of writing can save you minutes of outlining. Let's try another example. What does this do? I'll give you a second to try this out. Did you come up with C? It counts the number of positive values entered and stops at 0? If so, fantastic. That's what it does. So we're initializing count to 0. We've got while true. We're reading these values into num. If num's greater than or equal to 0, we're adding 1 to count. Else if num is equal to 0, we're breaking. Now, if num is less than 0, well, it's not greater than 0, it's not equal to 0. None of these ifs get triggered. We get to the bottom of the loop, we come up here, we do this again. So the only way to get to this break statement is to enter 0 for num, and the only time we increment count is when we enter a positive number. So we're just sort of looping through here. This is the indefinite part of the loop. How many values are we going to read? I don't know. We're going to read until we enter 0. If we enter 0 on the very first value, we don't read any positive numbers. If we enter 0 on the 53rd value and we enter 25 positive numbers in between, that's how many we read. We don't know. Unlike with a for loop, where we basically know how many times a for loop is going to execute because we have to set that stop condition for the for loop. That's actually all we've got for while loops. Thanks for listening, and I'll talk to you again soon.